All right. Hey, college stats people. This is Mr. O'Connell. And since I'm not going to be here the day before your final exam starts, this is Friday, May 12th, I thought I'd go over just the last couple problems on the study guide so you have a resource. Before you even start writing anything down, the teachers of this class at Prairie State and at Bloom and Trail decided that you'll be allowed a page of notes. It's not totally open note, but it's something. So if you write down as much notes as you want on a sheet of paper, go ahead and you can use it on the final Monday and Tuesday. So I'm going to start with number 12 and then snake back around. You and your family sit down to play a game of Monopoly. You can choose from playing as the race car, the thimble, the dog, the top hat, the cat, the wheelbarrow, the shoe, or the battleship. A. What is the theoretical probability if you choose a token at random that you choose the cat? So that's about as easy as it gets. That the cat is just one out of 1, 2, 3, 4, 5, 6, 7, 8 options. So theoretically, 1 out of 8. You might even hear one of the cats in the background. So that was not planned. That's just ironic, I guess. If you wanted to test the theory that people choose the cat more often than any other playing token, this gets into a hypothesis test. So if it's just by random, you should expect to get somebody who chooses the cat just 1 out of 8. If it's just by random, 1/8 of the time. 1/8 is 0.125. Either of those are fine. The alternate hypothesis, remember, the number stays the same, 1/8. By the way, this looks like a not good equal sign. I should also add, hang on. Not just the 1/8. The population proportion, the percent, is 1/8. Or pi is 0.125. The alternative hypothesis is that that people choose the cat more often. Variable stays the same, the number stays the same, but we're challenging that it's more than. So number is the same, variable is the same, sign is different. And the null hypothesis will always start with an equal to. So C, suppose you polled 75 random people and asked them what token they would choose in Monopoly. 16 replied with the cat. So we're going to find out, is that weird? Or how far away is that from our predicted 1/8? So start by actually finding the percent that found the hat. That's a p hat. I'm sorry, the percent that chose the cat. And that would be 16. Bless me. 16 out of 75, which is, I believe, 21%. Again. So we'll use this in a second, but it's good to write to the side. So the standard error, standard deviation, that was the equation right here. I bet that makes its way onto your note card somewhere, if you choose to make one. But actually, in this case, we're not going to use the p-hat. I'm sorry, that's a mistake. When we're using a hypothesis test, we're going to use the null hypothesis. If we were using a confidence interval, we would have used a p-hat. So in this case, pi would be 125, 1 minus 125, 0.125, decimal point is there, not here, over the sample size was 75. You should get 0.38. If you round that to 0.04, that's just fine. Z-score formula would be the sample minus the parameter over standard deviation. Our p-hat, this is where this p-hat up here comes in. So we would have 0.21, the sample, versus the null hypothesis. The parameter we hypothesized was 125. So about 21% versus 12 or 13%. They are different, but are they statistically significantly different? Well, we get a z-score to find out. 0.2125. So remember, anything over 2 is pretty rare. So we should think that this is an unusual occurrence. To find out exactly how unusual, we find the normal probability p-value, which is normal CDF. In this case, since we have a z-score that's over 2, our low bound here would have actually been our z-score, which is 2.125. High bound, say something arbitrarily big like 10. If we have z-scores, we have a 0 and a 1. Plug all that in. I'll let you pause and do that. Or I'll just keep doing this. That's a 0. So about 0.1679. So right about 1.7%. That's not the only way to do that. You also could have put in the actual mean where the you could have put the actual mean of 125 there, standard deviation of 0.04, and then you actually would have gone up to see where 21% was. You could have done that as well. Either way, the normal CDF function is going to give you about 1.7%. So make your conclusion. Are you with alpha level 05? Remember, you're going to reject if you're under the alpha level. So we found the probability of about 1.7%. Our alpha level's 05. It's under the alpha level, so we're going to reject the null hypothesis. If the p-value was something like 0.08, then you would have failed to reject the null hypothesis because it's above your alpha 0.05. You will never, ever, ever accept a null hypothesis. 13. What is this one gets a little bit further away. What is the only appropriate hypothesis test without any errors? How ironic. Without any errors actually has a spelling error. There's 2 of these that are totally fine. I stole this from a question from a previous test of yours, so it should look familiar. In this context, there's 2 that have errors, 2 that don't. The hypotheses are always supposed to be about a population. So number 4 right here, you should eliminate because X bar is part of a sample. Mu is part of the population. Also, like I said earlier, the numbers have to be the same. So you could also eliminate number 3. I remember the problem that this was actually taken from. You had to determine whether 4.5 or 10.9 was from a population or a sample. Since I didn't give you the context this time, both of these could feasibly be right. But if the problem said that 4.5 was from a sample and 10.9 was from the population, then I'd be able to eliminate the first one. Something we didn't really talk about, but there's a question on the final. Don't worry about it. A scatter plot with negative association. I don't think this should be a big deal. You should probably have seen this at some point in Algebra 1 or even pre-algebra or something. If you see a scatter plot that generally is descending from left to right, if it's descending, it has a negative association. This is a generally pretty strong negative association. A very strong negative association would be if it was in a perfect line. The one thing that it doesn't really talk about, there's a question on the test that we didn't really talk about, is an R value. If an R value is perfect, it would be -1. This is strong, so it would be close to -1, so maybe -0.8. But if it's all over the place, then it's going to be really close to 0. All right, the next video is going to be problems 8 and 9.